And this is the final chapter of Keith Stanovich's How to Think Straight About Psychology. And the topic for Stanovich is the image problem in psychology. I've changed this a little bit to call it pop science and self-help literature. How these are two of the problems that rationally thinking psychologists and social scientists have to tackle in order to think clearly about their disciplines. I don't think that psychology has an image problem in the sense that most people look down their noses at psychology. Particularly over the last 15 years, psychology has gained in popularity to the point that most people, at least in the West and in the United States, think very highly of the field of psychology. It's one of the most rapidly growing fields, professional fields, and people hold it in high esteem. And so there's a lot of trust in the applied discipline of psychology in particular, so clinical psychology, psychopharmacology, the biology of behavior and the biology of emotion, even the biology of things like exercise and art. It's a lot more accepted today than perhaps ever before in history. So it doesn't have that kind of image problem. However, Stanovich sort of helped me remember or recognize that there are still some image problems in psychology, mostly that deal with how psychologists and people who peddle themselves as psychologists, and I think this goes for sociology too, and possibly criminology and maybe economics, but people present themselves or peddle themselves as scientists when in fact what they're doing isn't the kind of rational application of scientific reasoning to their field and more advertising. We'll see like pop science and self-help literature are the ways that typically comes. So as a consumer of social science information and data and research, and then maybe as a practitioner, if you see for yourself a career in one of these fields, it's really important to be able to differentiate real scientific literature from imposter or faux or pop or pseudo-scientific literature. So I want to go through a couple of those in this discussion. So I've already mentioned, that I think that there isn't an image problem in the social sciences to the degree where people think, oh, that's not real science. I think that image has changed quite a bit. But that doesn't mean that the public image of social sciences is an accurate image. So pop social science I'm defining as anything that has been packaged to sell to consumers. So we've discussed a lot of research in this class or throughout this series of lectures. I've given lots of examples, and we've talked about how to design an experiment. We've talked about how to state a hypothesis and how it needs to be falsifiable and what happens if a hypothesis is non-falsifiable. And so we looked at all these different features of research design, and we spotted the errors, the common mistakes that are made, and how correcting those mistakes strengthens the kinds of claims we can have following the research that we've done or the kinds of conclusions that we can draw. Pop social science doesn't do any of that. And so what you have are studies that appear to have a well-designed hypothesis, a well-designed sampling strategy and data collection strategy and so on, and that the conclusions follow from that. But if you've gone through all of these different aspects of research design in the social sciences, you'll know which errors to spot, and the pop science literature commits a lot of those errors. And so if you read it carefully, or even if you get in the habit of spotting the errors, you know which errors to look for, you can discount pop psychology or pop sociology literature rather quickly and then discard it and not be compelled by the narrative that's being told or whatever product they're trying to sell. So I've listed a few things to look for. These are signs that a book, article, or podcast or a video are pseudoscience. And so one of the biggest red flags is that the person, whoever they may be, is vague about some detail or all details of the study that was conducted. Maybe they didn't even do it themselves, but if they did, they're vague about something. They don't talk about the sampling strategy. They don't talk about how many participants they used, so there could be, their finding could be a result of variance, or we looked at personal anecdotes or testimonials and how those aren't very reliable sources of data. But they're vague about that. So they don't say this is a personal opinion. They don't say that it's a testimonial or an anecdote. They don't say that there were only 10 participants in this study. They don't mention a control group. Maybe there's no placebo group. Maybe there's no baseline control group. And so something is missing. They don't refer to the underlying theoretical foundations, or if they introduce a new theoretical foundation, they don't do the connectivity principle, which means they use the new theoretical orientation to explain past theoretical principles. And so they don't work backwards with their new theory. They're just introducing a new theory and saying that the game has changed, essentially. So those are all probably the simplest red flags. If you can spot any of those things that are missing, then you have to suspend judgment. I'm sorry, until I know how big the sample was, until I know that there was a control group, I can't, the results don't mean anything to me. We've looked at hundreds of examples of that. Another thing to look out for is when the conclusions are sweeping. So they say, this tells us that we understand everything. I can't imagine a design that answers every question. There's always going to be 100 new questions that a well-designed study will generate, like 100 new questions. It was actually a principle of logical reasoning that was described by Robert Pirsig, and his book is then In the Art of Motorcycle Maintenance, which is a fantastic read if you're interested in American fiction. So if the conclusion is perfectly clear and it applies broadly and it's generalized widely, then you can predict that it was probably the result of someone who is being careless in their conclusions. This is something I see in inconsistent or contradictory use of scientific terminology, or the operational definitions that are used. And so I see this a lot in students, and I see this a lot in people who try to present themselves as scientists or as researchers. They'll introduce a topic, say it's like educational psychology or motivation, and then they'll conflate, and by conflate I mean they'll use the words interchangeably as if they mean the same thing, words that have very different definitions. So there's intrinsic motivation, for example, and then there's internalized motivation and externalized motivation, and different forms of each of them. But when they use like intrinsic and internalized as the same thing, they're missing a nuance there, and it confuses me as a researcher in educational psychology and motivation psychology as to what they're actually testing if they're conflating those words. I came up against this as well in the health psychology research I did a number of years ago, when let's say certain principles of pain are defined biologically in one sense, and then through like perceived pain. And so there's a biological measure in this scenario, and then maybe a subjective report in this other scenario. And those two things are used interchangeably, but really they're defined in different ways and have there's different theoretical understanding of what each of those definitions of pain means. And so when you conflate them, the reader doesn't know which one you're talking about anymore. So those sort of mistakes are made pretty often in pop science, or they'll use a word that has no established scientific definition. So the word for that we saw earlier in this series is operational definition. And then finally, if you're watching like a YouTube video or like listening to a podcast, and the person is advertising some like health supplement or maybe an antidepressant or some sort of training tool that you can buy, and the research they're presenting supports that, well, there's obviously a conflict of interest there. And so you have to be really careful about who is conducting the research and what they stand to gain from that. Now, a research study might have been designed perfectly. So, for example, testing a new antidepressant, there could be a control group, a placebo group, and the experimental group, and you can find that the experimental group had the best outcomes of all three groups, and there could be large sample sizes in each of those. And that would tell the reader, oh, wow, this was done really well. I don't see any red flags. But then you see that it was sponsored by a pharmacological company, someone trying to sell these drugs. But still, it was designed well. You don't see any red flags. But you don't know if the company, the pharmaceutical company, hasn't hidden some of the results that showed the drug was ineffective. So maybe 10 experiments were conducted and they only published studies 9 and 10. And so that's unethical. But if you're paying a scientist to do research, you get to decide which goes to publication and which does not. And so again, there's that conflict of interest. So it's something that you have to be aware of when you're listening to anyone report on research. Do they stand to gain anything by reporting on one outcome versus another? This is just a short list. I'm sure I could make it much longer if I spent a few weeks kind of generating these ideas or these examples. So how about some examples of pseudoscience and pop science in articles and books? So imagine you come across a book targeting parents of ADHD children, and it promises to solve ADHD family woes. In the book, phrases such as leading research shows and tons of research supports. This is actually, I'm pulling these quotes from articles that I've read over the last week, without any discussion of how the research was conducted. It's very easy, even for people who have PhDs, to say, oh, no, leading research shows or indicates that blah, 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 blah. And if they're unwilling to show you that research and how it was conducted and have some method of showing that it's leading and not simply examples, hand-selected examples, then what they're doing is overstating the importance of the research that was done or it's standing in the field. And those are red flags. Or imagine you're watching a pop sociology. I'm always trying to find examples of sociology because I'm a psychologist, but I've got students who are sociology students. So imagine you're watching a documentary about public education and some of the problems with public education in the Fulton County School District in Atlanta. There was a lot of problems with cheating on tests. So like entire institutions were like cheating, helping students cheat on their tests so that they could get better test scores. Then we can reflect on that and say, okay, so this is maybe a phenomenon of public schooling, and so maybe we need to do less public schooling. We can write a narrative explaining why, like using sociological principles, explaining why public schools are forced into this situation and that students would be better off with privatized education. I'm just giving this as an example. If you hear a documentary like this that does not explore alternative explanations or does not look at contradictory scenarios where their narrative doesn't play out, in other words, if someone says, this is the problem and here's why, and that's the end, then what they're doing is presenting a biased perspective. Any field in science lacks a definitive conclusion, so there are going to be multiple perspectives on any single issue. So the implication that there's only one way of solving a problem is going to be pseudoscientific. It's something that you need to be wary of. Now, I know if you are the person producing that sort of article or video, you want to say that your perspective is correct and give lots of examples that support you, but that's still, you're giving a biased perspective. So you would need to be able to bring in, you know what, not everyone agrees with me. Here are 3 people who disagree, and here are their arguments. And maybe here's my response to them, but what you're doing is providing both sides of the issue. And so that's why in the rubric that we've looked at through this class, one of the key level 4 type answers considers additional context. That's why it's so important. All right, another area where the public image is really important in the social sciences is the self-help literature, and this is particularly the case with psychology. So a self-help book is one written to you, kind of as like maybe a student or a parent, and it tells you how to solve some problem. And so it maybe makes two or three um, recommendations for what you can be doing now in your life to affect some sort of change. Now, those self help books may not go into the details of the research that supports why those changes are effective, or how, like, all of the nuances and details about how to enact those changes. Um, and in some cases, the self help literature is based on legitimate research that was conducted and takes into consideration all the demographic details that may interact with that change. So, for example, let's say as a college student, you read a book about how to get straight A's, and it tells you all about how to eat and how to sleep and like how to study. And so, um, what they're doing is drawing on studies about nutrition and sleep and study habits and cognitive psychology and memory and things like that. But they don't go through all of those studies. They don't describe how they were designed and what controls were used. So you have to trust that the studies they're following have been interpreted correctly and they were designed well. If the self help book you're reading follows well designed studies and draws conclusions that are applicable to you, then you're fine. But there's a good chance that the findings were stretched a bit to generalize to everybody, and maybe there were cases in which it's not very effective. The study habit might not be effective for you, but you don't hear about any of that. So you just do it kind of blindly. You follow the recipe in the self help literature, and you just hope that it works for you. It's not a very scientific way of consuming that literature, and in fact, you can't be a good scientific consumer of self help books because they're not very transparent. They just tell you what the research says, and you have to trust them. And so that's why most social scientists don't trust self help literature. They read the studies that the self help literature authors are referring to and then make their own conclusions. It's a lot more work, but you can trust that the conclusions are sound. I give the example here of research done in happiness, the psychology of happiness, and it was done by like putting he was French, a French Buddhist monk in an fMRI machine. I think this was at the University of Wisconsin in Madison Neuroscience Institute, led by Richard Davidson. This was like 20 years ago, and this monk was able to like meditate on happiness or like compassion or something, and there's this left prefrontal cortex activity, and they're like, oh, we've discovered the seat of happiness, and like there were books written about it and articles and movies, and I'm sure like and it was done kind of as a, let's see what happens when we put this guy into a fMRI machine. And so it's generated so much interest because what a cool narrative to tell. We found the neurological basis of happiness. So let's see. Yeah, even though it wasn't there wasn't a large sample size. It was one individual, so you can't. There were no controls. There was no placebo control. I'm not sure how that would be relevant, but there's there's so many red flags in that sort of a design. Yet it was extrapolated to go all these different directions, and so many generalizations were drawn. A lot of self-help literature does the same kind of thing. Wait a minute, like there was this one person who did something and it worked. Let me tell you the story. And it's scientifically grounded. I'm telling you that, even though I'm not being transparent in what that means. So a corollary to that is recipe knowledge. So I've already sort of mentioned it's when you follow the steps of the self-help book and hope that it works for you. So, for example, you and I don't know how our smartphones work exactly, or an application. We don't examine the code to figure out exactly how computations are calculated, and how algorithms work in the specific app. But we can still use it. It's simple enough to use. So the same may be true for like taking antidepressant medication. I don't care the neurobiology behind it as long as it works. And if it does work, I don't need to know the neurobiology behind it. But that only works if the recipe is accurate and accurate for you. And the only way to tell is to scrutinize the design strategy, the sampling strategy, and then perhaps test it on yourself. Not just kind of blindly accept that it works. It's not easy to do. It's a lot of extra work, and I use recipe knowledge for a lot of things. But for things that are important to me, I prefer to figure things out on my own and actually examine the data. Um, Especially if something doesn't sound right to me, I'll do the research myself. All right, social science and the media. This is how the media likes to twist results of studies. So, um, this actually happened when I first started working here. So I was a new PhD psychology professor, and I got a phone call from the local newspaper, and they told me about some study they came across and what their conclusion was about it, and how the citizens of our city will benefit. And they said, "Will you just give us your opinion so I can print this?" And I said, "Sure. Send me the article you're referring to, and I'll read it, and then I'll type up." I knew how important it was to be quick about this. I'll type it up. I'll get it to you by the end of the day. And I never heard from them again. They just wanted a soundbite. They wanted someone with a PhD to give an opinion consistent with what their opinion was, and then print it. But I didn't want to give an opinion. I wanted to give an actually educated assessment and analysis, something grounded in principles of scientific reasoning. And they didn't want that. They just wanted They wanted to sell a story. So media are interested in selling narratives, narratives about better living, about better health, about happiness, about improving well-being, and so on, or the reverse. They want to talk about how horrible things are, and so they're trying to sell these narratives. And scientific research seldom fits into narratives because they don't have these long narrative arcs with satisfying conclusions. You're making tiny little steps, and those tiny steps add up over time, but we want to get to the end as soon as possible. And so most media outlets are trying to get to the end, even if the research is inconclusive or insufficiently conclusive. So, in general, this is the last little point, scientists are extremely careful whenever they state a conclusion. Conclusions are generally tentative, and if there's a conclusion to state at all, there's always care taken in how far to take that conclusion. So it's not, I found that antidepressants were effective with this cohort of college students, therefore anyone benefits. No, it's therefore this one group benefited, and here's why I think it won't apply to another similar cohort in a different university or a different region of the world. So it's always like, it might seem like the conclusion goes this far, but the cautious scientist, is always saying, I'm worried about taking it too far. So let's just ratchet it back a little bit. And so this is what I'm confident saying. Scientists will always do that rather than the reverse. But the reverse is what sells. I found something that's going to change the world. That's what media outlets want to sell. So why would news outlets want to print a story with misleading conclusions? And ultimately, it's because people want to know that it's all figured out. But people who know a lot about a topic always realize the more that they know, the more there is to know. So having a PhD doesn't mean you have all the answers. It means you know where all the dark spots are, the blind spots are. So you're more aware of the mistakes that are made rather than you don't make mistakes anymore. So I have an example here. I just typed in eye movement desensitization therapy because it came up in this book, and it's still being talked about in the American Psychological Association. This 2006 edition of How to Think Straight About Psychology was talking about how eye movement desensitization therapy results were inconclusive, yet it was still being taught as this cure for, in this example, post-traumatic stress disorder. It's also been used for like children with anger management issues and life trauma and things like that. So I just typed it up and looked, and there was this article published by the APA, and I was curious if they said it's inconclusive in the article, but they don't. They talk about how to do it and evidence that it works. And I looked at the evidence, and there were like 8 articles, and all of them were case studies that did not employ controls. It was testimonial essentially, but more detailed analysis of what happened. So it was someone could follow that and derive a clinical application. So it was detailed in that regard. But in terms of does it work better than any other therapy, that assessment wasn't made. That analysis wasn't drawn. That data wasn't collected. And so I found it interesting that here we are 20 years later, And the same kind of narrative is out there. It's being done. There's evidence that it works, but that evidence was collected in a way that we would look at and say, okay, well, it's inconclusive. That doesn't tell us beyond a shadow of doubt that it works better than watching television, for example. So the last thing I want to say is that social scientists with PhDs are not exempt from making mistakes. Having a PhD does not make me any less likely to imagine an illusory correlation, or to imagine that I have more control than I do, or imagine that I didn't make any mistakes or have some sort of bias in the way that I designed a study. The PhD does teach me, or the training of getting a PhD taught me how to make fewer mistakes, or how to recognize mistakes and how impactful those mistakes will be. Before that training, I might have been more naive. I might have imagined that mistakes were unlikely, or they wouldn't affect the outcomes of research. Or I would read research and think, oh, that must be right because it sounds right. I wouldn't accept that, okay, things might sound right and still be wrong. Or a study could look good even though it makes all sorts of errors. So the main difference between the PhD and the non-PhD is that the PhD spots more possible errors than the non-PhD. It's like the quote from Einstein, and I'm paraphrasing. The genius doesn't make fewer mistakes than the non-genius. The genius simply recognizes the mistakes more quickly. So I think a lot of students want to have the PhD because it'll give them some sort of social power. But really, the power it gives you is recognizing that PhDs aren't anything special. So if you hear about someone with a PhD that conducted a study, you'll know, now that you have a PhD, that they're just as likely to make errors as anybody else. And so you'll scrutinize them just as carefully as you'd scrutinize anybody else.